Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at lccc. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. This video will review error analysis as it is used in the physics labs here at lccc. The absolute error, or in other words, is called numerical error, is the uncertainty in a measurement which is expressed using the relevant units in a plus-minus format. For example, we have here 50 foot plus or minus 1 foot. That plus or minus 1 foot is the absolute error. So it's important to remember that you decide what the absolute error is every time you take a measurement with a measuring instrument. So if you're using a ruler and you measure something to be 13 inches or whatever, you need to also consider to what accuracy do you have or what certainty do you have in that measurement. And so I'll often have, I'm a tutor here, often have a student come in and ask me what the absolute error is for the ruler they used. And I have to ask them, I said, it's up to you to decide what that error is. How good are you able to read that ruler? What is your plus or minus? If you're measuring in inches, how good of a value do you think you could read? So be cognizant of that you'll be determining the absolute error. However, occasionally you're going to use an instrument that may have its absolute error already listed. Particularly if you have some instrument that has a digital readout, it'll normally list their plus or minus what their measurement certainty is. Or sometimes the lab instructor will provide you with the absolute error. Now, there is also no such thing as zero error. Another common mistakes occasionally made. Any measurement that you take, if you're reading something off a scale or whatever, there's always some type of plus or minus value to that measurement. Just how good can your eyes, see that value? So there is no such thing as zero error. Now, when multiple measurements are made, so if you're measuring the same thing 3-4 times, the absolute error will be the average variation in those measurements. And then if there is no variation, meaning if you took 5 runs on a particular experiment and you got the exact same answer every time, then there is no variation. You just calculate your regular absolute error. But normally you would have more than one measurement or variation. You would get different numbers as you repeated the experiment. And what you would do is calculate the average variation, which is taking your highest measurement minus your lowest and then dividing it by 2. And that would be your absolute error for those 4 or 5, however many measurements you took. Now, another term that you'll be using in lab is percent error. And that's simply expressing as a percentage the uncertainty of your measurement. So your percent error is that you would take your absolute error that you measured, divide that by the measured quantity, and multiply it by 100. So for the example we did before, we said we have 50 foot with plus or minus 1 foot. So that absolute error was 1 foot divided by the 50 foot times 100. And that'll give you a 2% error is the way you would work that out. Now, occasionally you're asked for your percent difference between 2 values. So you might run 2 experiments that are different experiments, but they should result in the same answer. 2 different ways to determine a certain property of a material. So
when you have, so you're asked sometimes, what is the percent difference between the two different methods you use to come up with this value? And so if you know one of the values is accepted, you know that's the correct value, or if the teacher tells you, your lab instructor, that you're going to do one with an automatic instrument and the other one you're going to do by hand, these two experiments, and he tells you that you're to accept the answer that is done by the instrument, that one is right, and then tell me your percent difference on how well you did it by hand. So if you have an accepted value, then your percent difference is you take the difference between the two numbers and you divide it by the accepted value. This term here, you take the absolute value of that. So whether it's a minus or a plus value, you just use the plus term and multiply it by 100. And when you have the situation where there is no accepted value, where you did it two different methods to come up with the same number, and neither one of them are the accepted correct way of doing it, say, then they both have equal value. You would just take the difference between your two measurements and divide it by the average of the two measurements, and then multiply by 100. And that will get you your percent difference between the two values. And then if you're rounding your error messages, or you need to round your error messages, your absolute error and the measurement itself for your answer should be in agreement with one another in decimal places. So above, when we did plus or minus 1 foot, we had 50 foot plus or minus 1 foot. This is to the single decimal. The decimal place here is the single digits, and that's what our plus or minus absolute value was too. If we had, say, instead, let me erase this, say we had come up with an answer of 50.5 feet plus or minus 1 foot, then we would change the 50.5 feet to 51 feet plus or minus 1 foot, so that they had the same decimal place between the measured value and your absolute error. Now finally, you will occasionally have to do operations with your error values. You may be adding and subtracting numbers, multiplying, division, raising to a power, etc. So there are some rules here to go by. If you're adding or subtracting two values, two numbers with absolute errors, you're going to take their absolute errors and add them together. However, if you're going to multiply two values with error, you don't multiply or divide anything with their absolute errors. You calculate the percent error on each value, and then you add the 2% errors together. So sometimes you'll have to convert your absolute errors to percent and then do an addition here of the percent errors. And that's how you undergo a multiplication division problem with errors in it. Now, if you have to do a multiplication division of your values by a number having no error, so if you got to take a number and divide it by 2 or something, what you would do is multiply or divide that absolute error by that number. Your percent error will not change in this situation. So if you've already calculated percent error, it won't change. But if you have a absolute error for a value, and now you're going to divide or multiply that value by something, then you need to multiply or divide that absolute error by that value. When you raise to a power, if you're going to take a measured number with an error and you're going to raise it to some exponent, you need to multiply the percent error by that power. So multiplying percent error. Again, if you don't have percent error calculated yet, you have your absolute. You need to go and calculate the percent error first, then use that percent error and multiply it by the power to get your revised percent error on your final value. And then if you have a function, like taking a sine or a cosine of a measurement, then Here you would calculate the extreme values, where you would take your absolute, your plus or minus. You would, so if you have a plus or minus 1, you would calculate, say you're doing sine, you would do the sine of the value plus 1, and then take sine of that value at a minus 1 to get your two extreme values. And then your absolute error is 1/2 of the difference between those two numbers. So it's just a methodology to use when you're using a function involved with a measurement number. Thank you.